This is video number 3 on the navigation exercise for AER 110 online, Sand Hills Community College. In our first two videos, number 1 we did the courses and plotted out on our Charlotte sectional and the headings. On our second one we got our courses here and our checkpoints. We from our map we got our headings here, our true headings. We know our altitude that we're going to be cruising at. From the problem, we've got the winds and the temperature at altitude. We figured out our indicated airspeed was going to be 110 as we cruised, 75 as we climbed, and then we use our pressure, altitude, and temperature on our E6 to convert to true airspeed. So our cruising at 110 gave us a true airspeed of 114. Then we corrected our headings for our crosswind, or in this case, when we turn south, our headwind. And then we also corrected for variation and deviation to get our compass heading. So when we took off and turned to 265, we actually were steering 263 on our magnetic compass in the airplane. When we turned south, our true heading was 195, but we were actually on our compass heading steering 200 because we almost had a headwind, so our angle was only -1 degrees. Again, 8 degrees for our variation. That's based on where we're located on the Earth, and then -2 for the airplane. So we went from 194 to actually on our compass steering 200. And that's the next thing that we need to do is get our distances for each leg, which we measured. Here's our complete distance, 72 miles. Our distance to the top of climb was based on 75 knots and 5 minutes to climb, which you can do on your E6, and that gave us 6 minutes, or excuse me, 6 miles. So 6 miles to climb. Take that away from 72, that gives us 66 left in the entire trip. From there to the first, since it was 10 miles all the way to the VOR, and it took us 6 to get to altitude, we got 4 left, and now we're down to 62 miles. Now, the legs I just measured on the chart. So it was 15 miles from the VOR down to the raceway, 22 down from the raceway to Bennettsville, and then another 20 from Bennettsville down to our descent point as we cross the highway on I-20. Now, all of this I just took from the measurements that we did on the Charlotte sectional. Now, the ground speed that you're going to do is you've got to correct for the wind. And you know, do you do that directly from the true airspeed? And then we did it off the grommet on the back side, and we figured out our ground speed. So as we had a crosswind, not much of a change. We were truing out at 114, and the wind was slowing us down just a little bit, maybe 2 knots, because it was almost a direct crosswind. As we turned south, we were truing out at 114 again, but we had a headwind, about a 10-knot headwind. Okay, well, we were going 195, and the wind was from that 190. So you can see that's why we had a 10-knot headwind, and so our ground speed was about 104. Now, with that information, now that we have the distance and the ground speed, then you can find your times en route right here. Our time off, we were going to say it was about 1200 Zulu. Always use Zulu time. Right now we are -5 on daylight savings time. But we proposed off based on the problem at 1200 Zulu. So how do we figure this? This is just a distance, speed, time problem. So let's just do one on the E6B for a refresher. Let's check the leg between when we turn south from the VOR to go towards Richmond Raceway. How long is it going to take us to do that 15 miles at 104 knots. Okay, and that's where we're going to fill in right here. So let's go right here. All right, we said we're going 104 knots. So again, you use the index here and go over to 104, which there's a 10, and then 4 more ticks to the right. There's the 104 right there. Okay, and we said we need to go 15 nautical miles. So there's the 104, if I've got that right. Yep, 104. And then you go over here to the 15 nautical miles, and it's about 8.5 minutes. And since it's more than half, I'm going to round it up to 9 minutes. Okay, you can see that leg is going to be 9 minutes. With that information, I'll go ahead and put that right here into that leg, and now I have the time. Okay, now I did that exact same calculation. I'll do one more for, this is 22 miles at 104. Okay, how long is it going to take me? Well, I've got 13 minutes there. Let's look how we did it. We're still at 104 knots, but now we're going 20 miles, or 22. Let me double check. It was 22 miles. Okay, so instead of the 15, now we'll go over here to the 22 right here and look down, and it's a little bit more than 12 and a half, so I'm going to estimate it at 13 minutes. Okay, if you want to do it to the exact minute and seconds, you can. I don't think that gives us, I think doing 13 minutes would be close enough for us. Okay, so that's how I got 13 minutes here. Did the same thing, took my 104 and hit the 20, found out 12 minutes, and then 5 miles at 104 after my descent point into the airport, and 3 minutes. So all I did here was with a time off of 1200. Okay, well, 5 minutes later, 1205, 1207. And on this ATA, you can see this is estimated time en route, estimated arrival time, and my ATA is actual. Now, what I'll have is I have this nav log with me on my knee board, and as I get to each checkpoint, I'll fill in my actual time to see if I'm tracking like I planned, or if I'm ahead, if I'm fast, if I'm slow, and that way I can track my actual flight. The last thing we're going to do on the nav log calculation-wise is our fuel planning. Okay, we're going to start our fuel planning according to the problem, and I wrote it down up here just to start with 43 gallons, and I put it in the notes just to remind me. And we said in the problem that, and this is fairly typical for a 172, about 1.5 gallons, a little bit less than that for start, taxi, takeoff, and about another 1.5 gallons for climb to altitude to 2,500 feet. So you can estimate about 3 gallons to get to your cruise altitude. So that's what I did here, burning a planned burn of 10 gallons per hour. Now, Cessna 172s, depending on your day, normally burn between 8 and 9 gallons of fuel every hour. But if I plan at 10, that gives me a little bit of a cushion. So that's what we'll do. We'll plan at 10 gallons per hour. So I took off with 43 right here. And by the time I got up to cruise altitude, I had burned 3 gallons, leaving me with 40. Okay. Now, for the rest of these, basically I'm doing a 10 gallons per hour planning, and I'm using the times here to calculate my fuel burn. So let's go up here and remember how to do that. So I'm going to put my index on my 10 gallons per hour right there, and then just read the time on the B scale, and then that would tell me how many gallons per hour on the outside scale. So in at 10 gallons per hour, I can go around and say how at 9 minutes I'm going to burn 15 gallons. Okay, or 10 gallons per hour at 90 minutes, I'm going to burn an hour, 15 gallons. Okay, at 9 minutes, it would be a 1.5 gallons. So you can see that right there. Okay, so 10 gallons per hour, 90 minutes, I'm going to burn a gallon, 15 gallons. 9 minutes, 1.5 gallons. So you can see that's what I am going to calculate. So I go back and look, all right, 9 minutes. Oh, all right, I know I'm going to burn about 1.5 gallons. Okay, so every time I do a calculation, in 2 minutes, I'm going to burn about 0.4. In 9 minutes, I'm going to burn a gallon and a half, just like I said. 13 minutes, I go back down. I'm still burning 10 per hour. I go over here to the 13 minutes. Let's see, right there. And there you go, 13 minutes. And I look up, it's going to be about 2.2 gallons. Okay, give or take a little bit. So you can see here on the outside, it's about 2.2 gallons. All right, so there it is, 2.2 gallons. In 12 minutes, it's about 2 gallons. So every time I come down here, I take it away. I'm going to burn a total of 9.6 gallons right here. And then I just take away, and just as I'm flying the route, I'm checking my, my fuel gauge to make sure I'm tracking and burning what I should. Okay. The other thing I'm going to determine once I get there, am I going to need to get gas to get back? Well, at 10 gallons per hour with 33 gallons on board, you basically have 3.5 hours of fuel to get back. And it's about a 44 to 45 minute flight to get back, so you're not going to need gas. The last thing to do on your planning is to make sure you have all your information. You're going to want to get your destination weather, your departure weather. I went ahead and put that in. You can get this. You can write down when you get your ATIS, or when you're doing your planning, when you call 1-800 weather brief, and get your frequencies. Use your airport. You can just look it up online, get your airport information, or you can get this information right off the chart. All of this information is on the chart on your airport heading. So there's your ATIS. There's your SOP doesn't have a ground and tower because it's uncontrolled. Departure, if you want to go departure or have to, that's Fayetteville Approach 127.8. Really don't need to talk to them. CTAF in the pattern, there you go, 123. Flight service, Raleigh Flight Service, and I wrote that up here just to remind me, Raleigh Flight Service up there. And then Unicom is 123.05 in the pattern as well, field elevation 469. When you get ready to get down to Florence, about 10 miles out, you're going to want to hit the ATIS, 123.265. At that 5-mile point, when you cross I-20, then you want to switch to 125.1 and call the tower for clearance into the runways. Your flight service there is 122.6, which is Anderson Radio. Your Unicom, if you need to talk to somebody else, or the flight service station, not flight service station, the FBO, there you go. They'll be on 122.95, and the field elevation is 197. And someplace up here you might want to, Florence has cross runways. You want to write someplace down here what the runway headings are, so you can anticipate with a southerly wind what duty runway you're going to be using down there. So that completes our planning, and what I want you to do is do the exact same thing. Do your route here, your course headings, and your altitude for 3,500 coming back. Use the same winds and temperature. That'll work just fine for this problem. Do your calibrated airspeed, and then use the back of your E6 to get your heading and your ground speed adjustment. There's your ground speed over here. Then put the length of your legs in here. Figure out your compass heading. And then your time en route and your fuel burn on the way back. Okay. Turn those in to me on Moodle.